okay, software platform as well as hardware platform is required. Okay, so we'll be moving into a graphical programming language. Just an introduction about the purview of LabVIEW, and then what okay, software platform as well as hardware platform is required. Okay, so we'll be moving into a graphical programming language. Just an introduction about the purview of LabVIEW, and then what okay, software platform as well as hardware platform is required. Okay, so we'll be moving into a graphical programming language. Senior application engineer in PI Solutions, Bangalore. So we are the test and automation company. So and we're the technical partners of National Instruments. So we work on a lot of industrial projects as well as we are supporting the academic people on NI technology by just sharing their knowledge or industrial knowledge to the students as well as the faculties. Fine. So basically what we BI Solution will do, so we provide solutions, okay, and we provide support for system engineering and we develop products for a wide range of applications actually. Fine. So, and we are providing solutions for embedded system based applications. We build AD based systems. We develop data acquisition system applications, and we work on avionics and aerospace industry projects like product development, testing the aircraft engines, right, and the LRUs, line control units, and then we work on wireless communication. Fine. So these are the various sectors of various industries. These solutions will provide support to solve the engineering problems, right? As well as we are supporting the academic people also, right? On conducting FTPs as well as organizing the student workshop programs as well as internship for students. Okay, so as today's topic is on Internet of Things, okay, Internet of Things. So what exactly Internet of Things? Okay, basically when we ask the question, what is IoT? Okay, so when things started to communicate among themselves using internet as a medium, right? So we call that as actually IoT, okay, right? So things is nothing but a non-living being which is going to share the information to other thing, not a human, to the other thing, okay, by using internet as a medium over here, right? So if you see from where this IoT has come to share right? So we have facility like so we are the and they so and the so we use carrying that we just the other factor. When the internet is coming to picture, and I started to share the information through internet. Okay, just the best example, students as well. I can tell you now. So in this company, what we share here for the past 2 years provides solutions. Okay, we provide support whatever and we develop products for happening around the world. Okay, guys, learning and we are providing solutions testing like it's an online based systems and we are connecting system applications and we work on avionics and aerospace industry and products and product development testing 2020. Okay, so we are to share the information and communicate to the internet as well as simple example if I say with the connection of disconnected and what the internet as a second is on the internet can share the information easily. So what is the internet together as a connection will right is second we are marketing a lot of information right. So that's how internet of things is right. Okay, next value is internet of things the information okay other things started to communicate each other using internet of things right. So we achieve what we compare that internet of things it's an online being, it's going to be a sensor or it's going to be an electronic device, okay, or a form, right? So which is going to do some job, okay? For example, if I have a temperature sensor, what a temperature sensor will do? It's going to measure the ambient temperature or room temperature or the body temperature. Fine. So if I want to know what is the temperature value, so we used to monitor through this. Okay, we'll take it before thermometer. Now digital thermometer has come into picture, which is going to measure the temperature value. And if it is a smart thermometer, okay, it is a smart device which has a capability to connect with the internet, and if it has an ability to share the information through internet to a doctor or nurse, okay, so where we can achieve what internet of things has the ability to sense. Okay, sensing is nothing but measuring some parameters, okay, and it has a capability to communicate with other things, okay, so using internet as a medium, right, we can achieve internet of things here, right. So if you see, right, so the basic thing, when we talk about humans, okay, so brain is like a controller where we can sense, okay, we can see through note, okay, and we can view or we can watch the information, and that information will be sent to brain, okay, and we can hear, and those information will be sent to brain, and that will be processed, and then it is going to give a command. Based on that, we are going to take some action, okay. When things comes into picture, when things comes into picture, right, things doesn't have brain over there, okay, things doesn't have brain. So what we will do, the controllers, whatever we use is going to act like a brain, where we people is going to develop the logics, okay, and we people will be developing the code whenever the device sends a data, okay, whenever the device sends a data, and that information is given to the controller will receive the data, it's going to take some action. Okay, so that's how we can achieve what? An Internet of IoT based smart device. Okay, so simple example, before we'll have a watch where we used to watch movie, that we see the time. Now if you see, we have smart watch, okay, and where we can measure the body temperature, we can measure the beats per minute. If you walk for 1 hour, it is going to tell you how much number of beats you have just walked, and it is going to tell your heartbeat rate also, right? So how it is happening? We are creating what? Smart devices. Okay, when these devices has an option to connect through internet, right? These information may be shared to a doctor where we can maintain or we can have a patient monitoring system. Okay, so mobile phone. If you take the best example is mobile phone. Whatever we want, we can search in Google and we can get the information on the same place itself. Okay, so this is how things will sense. Okay, and then it is going to share the information. So how we can build an IoT device. Okay, that's going to be the next thing. How we can develop or how we can build an IoT device. Okay, an individual IoT device. Fine. If you see sensors, okay, the basic components to build an IoT device is going to be what? Sensors. Okay, so sensors are used to measure what? Physical parameters that will be converted into electrical information, and that will be given to the control unit. Okay, so if you see, we will be having different sensors to measure different parameters. Okay, and the next thing, if you see, we have control units. Okay, we have control units where the control unit is nothing but a controller, where it can be an FPGA-based system or embedded-based ARM processor or a microcontroller or an Arduino or Raspberry, whatever it may be, which is going to have, okay, which will be the important thing which will take the decision over there. Okay, and as it is an electronic device, if you use it in a remote base, we need to provide a power, so we need a battery for that, and communication medium, how it is going to transfer the information to another system. Okay, so like when we go for a wired, okay, when we go for a wired based system, right, we can go for Ethernet or any other protocol. If we go for wireless, so we're using Wi-Fi, and if it has the capability to connect with internet, okay, so we can transfer the information and we can build an IoT device. Okay, a single individual IoT device will have a communication medium, which will have a battery, will have sensors and a control unit. All together, we can build an individual IoT devices. Okay, if you see network of IoT devices, when different individual IoT devices, okay, so connected, and it can transfer the information among each other using internet as a medium, right? So we can achieve network of devices here. Fine. The next thing, if you see general thing, okay, when you see the general thing about Internet of Things, okay, so which is going to provide a better scope for data scientists, okay, and we can have a real-time analysis, right, and we can have a wide connectivity. Fine. So if you see the main thing for this Internet of Things, okay, which is required is going to be the general devices and the sensing devices. Okay, these two are the most important thing. The general devices are categorized, okay, as an embedded processor, or it can be a microcontroller based unit. Fine. And if you see the second one, this is going to be the connectivity for the platform. Okay, connectivity for the platform, where we can connect and we can share the information through wired mode. Okay, or else we can go for wireless mode in order to have a data transfer. And if you see the sensing devices, the sensing devices are what? Sensors which are going to measure the parameters, for example, temperature, noise, okay, in light intensity, okay, and if you want to measure the humidity, right? So like this, we can measure different parameters by using what? Sensors over there. Okay, so the general devices and the sensing devices are the major important thing for IoT system. Okay, the best example is what? Where the home appliances, okay, where the home appliances are controlled, okay, by sensors. Okay, so each sensor is going to help us to solve the problems. Okay, and if you see, we have what? Actuators. Okay, so what actuator is going to do? It's going to act like interface between your sensor and then it is and the machine here. Okay, so what it is going to do? It's going to collect the various informations like humidity, temperature, light intensity, whatever it may be. Okay, and these information is computed. Okay, these information will be computed using an edge layer. Okay, so using an edge layer which is placed between the cloud and then your sensors. Okay, right? So and these layers is going to what? Store the information. Okay, and it is going to store the information, and the cloud is the one which is going to act like a backend which will process the informations here. Fine. So this is how we can build an IoT based system. Okay, and if you see here, we know already devices, and the next one is going to be what? Connectivity. So connectivity, we know we can go for wired connection, or else we can go for a wireless connection. Okay, so if you see the next one, okay, of this Internet of Things, right, we have device management platform. Okay, we have something called device management platform. So this is going to interact with your software layer. Okay, this is going to interact with the software layer through your network gateway. Fine. So this device management platform performs various functions. You see here this one, device management platform here, which is going to perform various functions here. Okay, like firmware upgrade, security patching, and then like metric remote, alert mechanism. Okay, so all those things will be taken care by this device management. Okay, device management platform here, right? So if you see the connections, right? If you see the connections is going to be what? The backend. So where which will help us to have transfer the information. And the last one, if you see, we have applications here. So where we can process, where we can view the information in this application. Fine. So if you see in this, different communication protocols has been used for different applications, right? For example, Wi-Fi, okay, which is going to provide an internet access, which will help us to transfer the information. That is a basic thing which we will use. Okay, if you see the another communication protocol, which is opposite here, Bluetooth, where we can transfer the information, okay, through a shorter distance. Okay, so Bluetooth, we know only 10 meters, where we can have an exchange of data. Okay, when we have Wi-Fi with given bandwidth or given region, where we can transfer the information, okay, from one place to another place here. Okay, when you see the satellite communication, which will help us for cell phone communications here. Fine. So RFID, so which identifies the sensor and the objects. Okay, these are the different communication protocols which we can use in your Internet of Things over there. Fine. So there are various protocols over there. Fine. If you see here in this, okay, so next one, after this protocols, right, this is the most important thing, okay, which is called the architecture. Okay, the IoT architecture here. Okay, if you see this IoT architecture layer, right, it has 4 layers. Okay, if you see, it has 4 layers. Okay, so IoT device, next one IoT gateway or aggregation layer, we have processing engine or even processing layer, and the last one is going to be your application layer or API. API is nothing but application peripheral interface management. Okay, so these are the 4 layers of an IoT device architecture. Okay, so the basic layer out of these 4 layers, right, the basic layer is going to be the IoT device. Okay, the basic layer is going to be IoT device. Okay, so this layer will have all the components or all the devices like sensors. Okay, so which will help us to sense the information or sense the parameters. Okay, fine, and it is going to transfer those information. Okay, so IoT layer is going to be the what? The basic layer. Okay, and if you see the next one, okay, next if you see communication. Okay, how these devices can communicate, by using different protocols. Okay, so here we will use mostly HTTP protocol. HTTP protocol is hypertext transfer protocol. Okay, or else we can go for MQTT, message queue telemetry transfer protocol. Okay, these are different protocols which we will use, okay, in IoT, okay, in IoT based applications in order to transfer the data, okay, or in order to share the information among one device to another device, or one machine to another machine. Okay, so if you see this layer, okay, is going to aggregate what? This data. Okay, so if you see the next one, okay, after this communication layer, right, we have another layer called IoT gateway or aggregation layer. Fine. So what this layer is going to do, it's going to aggregate the data which we collect from the sensors over there. Okay, so the two layers is going to set what? A rule for the data aggregation. Fine. So one, we see, you can see here the next layer. Okay, after IoT gateway, right, we have another thing called processing engine or event processing layer over there. Okay, so this event processing layer or processing engine, which like a cloud where it has numerous algorithms, okay, which has numerous algorithms, and we should have the data processing elements. Okay, we should have data processing elements, right? So whenever we send any data through IoT devices, right, by having the IoT gateway through MQTT protocol or HTTP protocol, when those data are transferred, okay, through IoT gateway to the processing engines, right, at that places only the data will be collected. Okay, the data will be collected, and where will have lot of algorithms over there. So those data will be processed. Okay, those data will be processed. Okay, and then that will be given. Okay, the processed data will be given to the application layer or API management. Okay, so here if you see, we'll be having what, like web portal. Okay, so or we'll have dashboard application. Today we'll be discussing about dashboard applications, or we'll have API management. Okay, API management, where which is going to act like an interface between your third party application. Okay, so today I'll be showing a small demo how we can transfer the data from my mobile phone to my application. Okay, when my systems or devices are connected through internet. Okay, so the data dashboard application is a what? A third party application. So which through this application layer we can collect the data, and we can send some information from your dashboard to your IoT devices also. Okay, you see this entire landscape. Okay, you see this, all these, right, layers like IoT device, IoT gateway, processing engine or application layers, that will be supported by device manager. Okay, device manager, and we have another manager called identity and access managers. Fine. So these are useful for security. Fine. So where we can have data transfer between a machine to machine, okay, or a mobile to a machine, or from device to machines over there. Fine. So this is how the IoT architecture has been categorized into different layers, where each and every layer is going to perform, right, different tasks in order to build an IoT based system. Fine. So basically when Internet of Things comes into picture, right, so when we use it for a consumer based application, so we call that, okay, we call that as actually consumer IoT. Okay, consumer IoT, I can say like home consumer IoT. Okay, the best example is home automation, where the each and every equipment or the components in the home has been monitored and controlled by using internet as a medium over there. Fine. If you see on another hand, okay, that is the most important thing. If you see the another hand, we have what? Industrial Internet of Things. Okay, we have industrial Internet of Things. Right. So consumer IoTs through your mobile phone itself, you can just turn on and turn off, or if you can just monitor your home appliances in the home. And if you know, now we have a technology. Okay, so the smart technology where the device, when the refrigerator is connected to the device, and if it is trained properly, where it will tell you whether the like for example, if the milk packet is not available in the fridge, it will send information to the owner, okay, to the mobile, that inside the fridge the milk packets are not available, or if any groceries or vegetables, okay, or anything is not available, right, when that information can also be transferred to the people by using Internet of Things over there. Okay, so we'll see a small video. Okay, so how our entire world has been changed, okay, when Internet of Things has been comes into picture. Okay, let me show a small video. After that we'll discuss about industry 4.0, and then we'll be moving into demonstrations. Fine. So I'll just play a video.
It's crazy that we don't want to use energy for us.
You watch YouTube like a very
We can't keep this up.
Yeah, no.
1,400 transport units, 20,000 kilometers per second, 250 hours through. What do I need?
Microsoft Teams ఇప్పుడు పంపిస్తున్నాను వస్తుంది కదా
Social advantages. Where's the bunch? Oh, well, I still need to do this.
Don't you have the feeling we're standing still all the time? Why does it pick up on our minds? Isn't it strange that rays are getting longer? Will evolution make the world more efficient?
No, why can't we focus on people instead of procedures?
What if objects start to sense and communicate, becoming tools to help us deal with complex and emergent situations? What if all objects were interconnected? What if there was an Internet of Things? With the Internet of Things, applications are infinite. We could be able to monitor our transport better, winning precious time at any turn, with beyond smart logistics as we know it.
With an Internet of Things, we could be able to monitor from a distance. Instead of spending time in a hospital, people could actually live their lives.
Emptying our cars would be a thing of the past. It would also limit forgetfulness. We wouldn't even need a shopping list. We could easily ping our refrigerator at home to tell us what's missing.
If we want to be smart about energy, we could let energy be smart about itself. With the Internet of Things, we could be able to manage our world differently, adding a new dimension to the Internet as we know it.
The Internet of Things, part of our future.
If you see in the small video, okay, which tells you an information how the world has been before Internet of Things and after Internet of Things. Okay, so the best example they have seen is what a patient monitoring system. Okay, so when a patient arrives in hospital, he has to meet the doctor and they have to collect all the information about the patient before they meet the doctor. Okay, and once they are connected, okay, when the patient is connected, okay, to Internet of Things, where we'll be having the devices to measure each and every parameters like ECG, okay, the heartbeat, blood pressure. All those information will be shared to the hospitals by using Internet as a medium. So when they came to visit the doctor, right, they can directly get an appointment, and doctor will be already analyzed all about their health issues, and they can have a consultation and they come back. And the next one, if you see the transportation, whenever the devices are connected to the Internet, and if they have a capability to share the information, right, they can avoid the right. They can avoid, or they can get a fast route where they should not be get into trouble during the traffic issue. Okay, so where they can find the right path so that they can reach the destination at the right place. Okay, if you see another example where the person can ping to the refrigerator, and if you check whether any product is missing, and if it is missed out, so he can get the information from the refrigerator and he can buy the grocery or the required items. Okay, fine. So these are the things which we can just talk about. The consumer IoT, okay, where Internet of Things, okay, helps a lot, okay, in major applications. Fine. So if you see, the next one is going to be the industrial Internet of Things. Okay, so what exactly is industrial Internet of Things? Okay, how IoT plays a major role in industries. Okay, so that's what we're going to see about, okay, the next session. So what exactly as industrial Internet of Things. Okay, so when we discuss about IIoT, okay, when we talk about a word called industrial Internet of Things, right? So first we should know what exactly IIoT is. Okay, so where industrial Internet of Things, okay, which is going to use smart sensors, okay, and which is going to use what actuators, okay, to enhance the manufacturing and industrial process. Okay, so they'll call this industrial Internet of Things as Industry 4.0. Okay, which uses the power of smart machines, okay, and the real-time analysis, so which will take an advantage of the data, okay, that dump machines in industry settings. Okay, if you see here, when the sensors, okay, when the sensors and actuators are connected through internet, right? So which is going to enable the companies to pick up the inefficiencies and the problem, okay, so they can easily identify the problem, so they can rectify the problem in a very quick, in a very less time, and which is going to help them to save time, okay, and the money, okay, and which will support business intelligent effort. Okay, for example, if we are going to monitor the health monitoring system of a machine or a steam turbine, consider, okay, a steam turbine or wind turbine, right? So if we have a health monitoring system, right, when all these are connected through internet as a medium, and what are the sensors which we use are going to be a wireless sensor which can transfer the information through internet. So from our workstation, we can just monitor the condition of the machine, and if we can easily find out if there is any issue, right? So before when a major issue happens, so we can just monitor the parameters and we can just avoid the downtime. So we can fix the time to rectify the problem so that we can save the time as well as the money here. Okay, if you see how this Internet of Things works, okay, how this industrial Internet of Things works, right? So this IIoT is going to be a network, okay, it is going to be a network of intelligent devices, okay, so which is going to connect to form a system, okay, it will form a system to monitor, okay, and it will collect, and it is going to exchange, and it is going to analyze the data over there. Okay, so each and every industrial IoT ecosystem, okay, each and every industrial IoT ecosystem will consist of connected device. Okay, what is the use of devices which can sense, communicate, and it can store the information about themselves, right? And if you see the next one, there's public or private data communication infrastructure. Okay, third one, it's going to, and it has an analytics and application which is going to generate the business information for the raw data here, and it will store the data, okay, that is generated by the IoT devices and the people over there. Okay, fine. If you see the edge devices, okay, these edge devices, okay, and the intelligent assets, so which is going to transmit the information directly to the data communication infrastructure. Okay, fine. So where we have certain piece of machinery is operating, the information can be used for what? Predictive maintenance. Okay, predictive maintenance as well as to optimize our process over there. Okay, the predictive maintenance is very zones, okay, where places where the humans cannot move, right? Okay, if it is a remote place, they can have an aircraft, okay, so which it is like you can consider it like a drone or something, right? Which will help us to visualize and do thermal imaging, okay, to detect the problems in the pipelines here, okay. So these informations will be combined with the data from other type of sensors to have an ensure the safety operations, okay, to ensure the safety operations. This will be combined, like different informations will be collected, and we can have a predictive maintenance and we can have a predictive analysis, fine. So if you see the next one, what are the benefits, okay, what are the benefits of having internet of things, okay, industrial internet of things. So one of the best benefit of having your internet of things is what, in manufacturing industry, so as I told you, predictive maintenance, okay. So and the respective industries, they can use their real-time data, okay, they can use the real-time data which will be generated from their IoT based systems, okay, to predict when a machine will needed to be serviced, fine. So then, and then if in that case, if it is necessary, right, so they will be taking a proper maintenance, okay, before the failure can occur, fine. So this can easily help the industry for beneficial on their production line, okay. A failure of machine will result a work stoppage and huge cost, okay. If you see in industry, right, so for example, I think I have a small experience where I just viewed it, right. So where there will be a mobile phone charging manufacturing industry will be there, where they will be manufacturing a lot of charges, okay, and all the systems over there has been automated, and each and every sensors, each and every chargers will be assembled by the line people, okay, and that will be passed through the conveyor. Each and every line people. Sorry, I can hear my voice back. Is there any network issue? Hello. Ma'am, shall I continue or there is any network problem?
No, sir, we can hear you clearly.
Yes, ma'am. Okay, thank you so much, ma'am. If you see, right, in that charging manufacturing industries, right, so each and every components will be placed on the respective the PCB boards, and that will be passed to a machine where it will get automatic. The soldering will be taken care automatically, and then in like there will be some stages, okay, where those components will be break. Okay, the PCB board will break into small charging components, and that will be assembled inside the charger case, and that will be moved into the conveyor, okay, where they will be doing labeling and all. So in case when the conveyor has a problem, okay, so when it got stuck up, okay, when it got stuck up, there is any problem over there in the conveyor belt, right? So the entire process will get disturbed, because once the charger has been moved from one place to another place, only the next process will be taken care. So that duration, the time taken to solve the problem, okay, the time taken to solve the problem, okay, here in this case the conveyor belt has been damaged, okay, or the motor has been damaged, or if there is any problem, right, or it has been stuck, the time taken to rectify that issue will be considered as a downtime. So that will affect the charger manufacturing process, okay, all those things will be affected. That's what here they say, the downtime will be reduced, which will help us to increase the cost, okay, which will help us to increase the cost here, fine. So if you see here, the another benefits of having your internet of things, right, so it is more efficient in field services, okay. So this IoT technology helps field services technicians, okay, to identify the potential issues in the customer equipment before it has become into a major issue, okay. So by enabling the text, okay, so we can fix the problem, and then, okay, so before some inconvenience will be happen to the customers over there. If you see here, these technologies, right, so will help the field technicians, okay, the field technicians, okay, with the information about, okay, the part which has to be needed to be repaired, so that they can avoid a problem, okay, during the production line, okay. And if you see, the next thing is what, the asset tracking, okay. So it is another perk in your industrial internet of things, where the suppliers, the manufacturers and customers, okay, they can use the asset management system to track the location, status, and the condition of products throughout the supply chain. Okay, so now this is the most thing which all the industry people are doing. So whenever they provide any products, right, they're going to track the status of the product, and they're going to look the condition of the product, right? So if before the product is going to face any damage, they'll teach the people and they'll try to rectify the problem. Okay, so that the problem has been cleared over there. Fine. So which will help us, or which will give the feature for customer satisfaction. Okay, and the product are connected to internet, right, the manufacturers can capture and they can analyze the data. Okay, how the customer uses the product. Okay, and enabling manufacturers and product designers to build more user friendly product. Okay, right, so that the business also will get developed, right? So if you see here, whether the most important thing about IoT is what? Security, because we are transferring all the data through internet as a medium, right? The most important thing which we always look what is about security, fine. So if you see, the manufacturers who are going to create the IoT devices, right? Right. So before they didn't look about the security. Okay, so after when they look about the securities, right, so which is going to result in the perception of IoT devices. Okay, and right, so which we have to always take in care. Okay, because mostly we'll be transferring the data here through what, internet, right, and all those information will be in of text format. Okay, if you see, whenever we connect any devices, okay, whenever we connect this device to any other connected device, right, IoT devices should evaluate on a device, okay, by device basis, right? So if it is entirely possible, how it is possible that one manufacturer device is secured while another is not. Okay, so when security is a priority among the device manufacturers, right, so next cyber physical system, all those things comes into picture over there. Fine. So if you see, we see, I hope you people now understood what is the difference between a consumer IoT, normally we call as IoT, and then industrial internet of things here. Okay, if you see here, that mostly when you look about internet of things and the industrial internet of things have technologies in common, right, like cloud platform, sensors, connectivity, machine to machine communication, and data analytics, right? So they are used for different purposes. Okay, so the IoT application, which will connect the devices across multiple verticals like agriculture, healthcare, okay, enterprise, and consumers and utilities, okay, as well as for government and cities here. When you look on industrial internet of things application, okay, when you look on industrial internet of things application, right, on the other hand, so which connects machines and devices, okay, in industries like oil and gas, robotics, okay, utilities and manufacturing industries, where the system failure and downtime in your IoT deployment results in high risk situations. Fine. So the IoT applications are more concerned with improving efficiency and improving health or safety versus your nature of IoT applications, right? So if you see the different applications where IoT is used on, as I told you, in smart robotics, okay. So if you know, there is a company called ABB, okay. So where a power robotic firm is used to connect, okay, in any, I hope people know about ABB is a huge industry who provides various support on industrial automation. Okay, so they'll be providing a lot of support on robotics based applications also. Okay, so in the smart robots, right, so a power and a robotic firm uses connected sensors. Okay, it uses what? Sensors which will monitor the maintenance need of a robot. If you see, I can now most of the industries they have robots which is going to perform the task. Okay, if you see in the automotive industries, right, where each and every car parts have been moved from one place to another place through robot, and that will be assembled. Okay, and it will be assembled through what? Robot. So in order to have an health condition monitoring system, okay, of this robot, right, when we have the sensors which is going to measure each and every parameter of this robot, so before a failure occurs, they can easily predict, okay, and then rectify the issue, okay, before the parts will get breakdown. Okay, in the same way, if you see there is another company called Airbus, okay, who are manufacturing the aircraft. Okay, so they have commercial jetliners. Okay, so The Rapimus people have launched a system called Factory of Future, fine, a digital manufacturing initiative, okay, so which is going to streamline the operations and boost the productions here. So what they have done here is have integrated the sensors into the machines, okay, and it goes on the shop floor, as I told you, the same thing like the robotics also, okay. So they have just integrated what sensors on the machines on the shop floor, okay, and then they have outfitted the employees with their wearable technical gadgets like industrial smart glasses, okay, so which is aimed at cutting down the errors and enabling the safety for the people in their workplace, okay. So another example for application of IoT, industrial IoT, right? So we have another company called Fanuc. So they are the robotic manufacturers. Okay. So they are using sensors on the robots. Okay, along with the cloud-based data analytics. For what purpose? To predict the failure of the components in the robots. Fine. And then there is another company. Okay, called Magna Stat. So he's an Australian automotive manufacturer. Okay. So they are also using IoT for tracking the hazards as well as the vehicle parts. Fine. So the next one, so as I told you, right? Yes. How many questions?
Right, sir, changes.
Yes, ma'am. I have just made it as a points. I'm just explaining, sharing few information. That's all. Just now I have moved from one slide to another slide. Okay.
But the distance.
No problem. No problem. So if you see, right, these are the vendors actually. So the examples which I have moved and shared the information here. So these are the different vendors who are using industrial Internet of Things platform. So ABB. Okay. So they have it has a IoT company specialization, connectivity, software, and machine intelligence. Okay, you see there is another thing called Cisco IoT, which is known to every people. Cisco, which is IT for which is used for networking. Okay, so it's a networking company which is offering a lot of platforms for network connectivity management, data control, and for edge computing. Okay, if you see that we have another name, Siemens. Okay, so they have a IoT-based platform called MindSphere, okay, which is developed by the Siemens over there. So they are providing solutions, okay, based around artificial intelligence and advanced analytics. Fine. And if you see GE, the General Electrics, so they have a platform which is called Predix. Okay, they have a platform which is called Predix, which is used for connecting, optimizing, and scaling our digital industries. Okay, fine. So there are different vendors out there who is providing support for industrial Internet of Things, and most important thing for 5G. Okay, for the industrial Internet of Things and 5G together. Okay, so 5G is the most emerging standard for mobile networks now, right? So they have specially designed to deliver what they are going for 5G. So mainly for delivering fast download speed with low latency. Okay, so this 5G will support download speed up to 20 Gbps, right? So in terms of a millisecond latency. Okay, so where this IoT and 5G combined together also, it's going to provide a lot of support for us in the industry. It's fine. So if you see, this is the revolution of industry. Okay, if you see, right, this is the revolution of industry. Okay, evolved from industry 1.0 to industry 4.0 here. Okay, so we are now in industry 4.0. Okay, so if you see industry 4.0, right, it is a revolution. Okay, where the companies, the manufacturers improve and distribute their products over there. Fine. If you see, the manufacturers are integrated. Okay, the manufacturers are integrated with new technologies like including Internet of Things, cyber physical systems, cloud computing, and analytics and machine learning, right, into their product facilities to have a high throughput. Fine. So from how we have achieved this Internet of Things over there. Okay, so from where we have got this Internet of Things. If you see here, right. So the smart factories, now when we implement this industrial 4.0, industry 4.0, right? So we call that as a smart factories, where the smart factories has been equipped with the different advanced sensors, embedded softwares, and then robotics, which is going to collect analyze the data, okay, and it is going to allow us for a better decision making. Okay, so you see here this digital technology. Okay, you see this digital technology, right, which leads to increased automation, predictive maintenance, self optimization of process involvement. Okay, and which has a new level of efficiency, okay, and responsiveness to customer, okay, which is not possible before the industrial revolution. Okay, fine. So if you see here, right, developing the smart factories, okay, so which provides an incredible opportunities for manufacturing industries to enter into their fourth industrial revolution. Okay, so if you see here, right, so this in industry 4.0, by having this cyber physical system and internet of things, right, so we can analyze, okay, we can analyze a large amount of big data which will be collected from sensors on the factory floor. Okay, so and then we can provide a better predictive maintenance, okay, in order to minimize the downtime. If you see here the industry revolution, okay, the historic from industry 1.0 to industry 4.0. If you see industry 1.0, where the mechanization, steam power, and weaving, right? So if you see in this, the first industry revolution helps mass production. How? By using water, okay, by using water and the steam power instead of having human effort. Okay, if you see before, where humans as well as the animals are used for transportation purpose, where if you want to move any objects or any instrument from one place to another place, right, we'll be moving. So after that, they just moved into when we are into the industry 1.0, where mechanization comes into the picture, right? So we'll be using steam power as well as water, okay, to have a production for mass productions, right? So before we the human people will be doing all the jobs. If you see the second industry 2.0, okay, so which is the second industrial revolution, where the they introduced what assembly lines, okay, they introduced assembly lines, and they used what oil, gas, as well as electric power. Okay, so these new power resources, okay, along with the more advanced communications, right, so which help us to make a mass production, okay, and some degree of automation to the manufacturing process. Okay, see, when using the conveyors, we can just transfer the information, or we can move from one point to another point. If you see the third one, industry 3.0, where automation, computer, and electronics comes into picture, right? So where the computers, okay, and the advanced telecommunications and the data analytics has been added to the existing manufacturing process. Okay, if you see the digitization of factory began here, how? By having PLC, programmable logic controller. If we talk about national instrument, where your compact reuse as well as your PXIs as well as your data entry system, which is implemented in the machineries to automate some process, okay, and to collect and share the data. If you see industry 4.0, okay, so we are in industry 4.0 right now, and now people started to move to industry 5.0 also. Okay, fine. So here we are in this industry 4.0, right? So we are going to increase the automation. Okay, we are going to increase the automation and the employment of smart machines and smart factories. Okay, right? So which the data will help us to produce goods in a more efficient way and productivity across your system and the industry. If you see here, what are the different technologies? Okay, what are the different technology which they use in industry 4.0? One is your IoT, Internet of Things, which is the key component for the smart factory, where machines, okay, are equipped with the sensors, okay, that features an IP address, allows the machine to connect with another web-enabled devices where they can transfer the data. Next one, if you see, cloud computing, okay, that is the important thing. So which is concern of industry 4.0 stack, industry 4.0, and the third one, AI and machine learning, okay, artificial intelligence and the machine learning, which allows the companies to take advantage of a volume of information generated on the factory floor, okay, not only on the factory floor, across their business units. Okay, fine. And last one, edge computing, and then cyber physical system, okay, cyber security. Okay, all those, by having all those technologies only, we can build, okay, we can build industry 4.0. Okay, this is how a revolution has been happened from industry 1.0 to industry 4.0. Fine. So now if you see how we can achieve. Okay, so if you see here, so things, right, when they started to communicate among each other by using internet as a medium. Okay, so where it has been used in different aspects in consumer IoT as well as in industry IoT in order to have a data transfer mechanism, predictive analysis, okay, which will help us to increase the product manufacturing and the cost also. Fine. So this is about the Internet of Things introduction, about IoT, Industrial Internet of Things, why Industrial Internet of Things is needed, how Industry 4.0 has been evolved from Industry 1.0 to 4.0, and we are seeing about IoT architecture. Okay. Next step, we are going to see how NI, okay, how National Instrument is going to help us, or how NI is going to support for developing an IoT based systems. Okay, so now when we talk about industry, okay, IoT based system, right, how NI technology is going to help us to solve the problems. Okay, you can ask the question like, we have different industry, we have different hardwares which are help us to provide or develop applications, why NI technology is used, okay, and how NI technology is providing solutions for the engineering problems, and we'll be seeing what are the different industries who are using NI technology for developing applications and for getting solutions for their engineering problems. Okay, I'm going to play a small video which is about National Instrument, how NI technology is used in different industries for their engineering problems. Okay, fine. Now I'll just complete a small video which will tell you about an overview of NI.
Finding solutions relies on engineers and scientists test, measure, and control routes. During that time, our customers who use NI's integrated platform-based approach to build an endless list of innovative and awe-inspiring applications. But for the people who benefit from these efforts, it's something personal. It's about reducing those emissions. It's about making saves the lives of children without heart and creates new methods of wireless connectivity and communication. The kind of impact that leaves behind lasting solutions. Solutions for better environmental monitoring. Solutions for better disaster communication and solutions for life. Solutions for you. 40 years ago, we can't wait to see what happens next.
Okay, so in the small video you have just come across, okay, how NI is providing solutions on different engineering problems, how NI is giving solutions on different industry sectors. Okay, so same thing whatever you people have seen on slide, they're providing support to solve the engineering problems on semiconductor based industries, automotive. Okay, so now automotive when comes into picture, right, for electrical vehicles, that is the most important thing which is moving around the world, right? So for a battery management system, okay, and for simulating the okay, and to analyze the performance of the electric motors used in the in your electric vehicle, right? So they are developing HI hardware input systems where they can simulate the motor and they can check the performance of the motor in the system itself, okay. And for ABS anti-locking braking system, or for electronic control unit, okay, in order to test the electronic control unit present in the car. So they will be using NI technologies by using software as well as the hardware platforms. Okay, fine. If you see on aerospace and defense, right, where NI technology is used for testing their line control units LRUs, okay, to have a whether they're getting a right communication from one unit to another unit, okay, inside the hardware, and testing the engines, okay, aircraft engines, right? So in various aspects, right, they will be using NI technology over there. Okay, power. So now we are in the green technology where renewable energy is used for power generation. Okay, for power quality analysis, for building a renewable energy based systems and all, right. So they will be using NI hardware as well as software. So when wireless comes into picture, 5G. So NI has its separate family of hardware, which is mainly used for communication purpose, which is helped to develop. Implement a lot of communication-based algorithms and methodologies, and mainly for 5G research, NI hardware are providing a huge support for their analysis purpose. Okay, so like this, they are providing solutions for different engineering problems. Okay, so if you see how, okay, how can I answer question like how they are providing support? Okay, they are providing support. All right, so for engineering problems, two ways. Okay, one by providing the right software to develop their applications or to test the products, and the next one by providing the right hardware, okay, which will help them to build a real-time system, okay, in the easiest way, right? If you see the software which NI provides is LabVIEW, we have Testan, we have Multisim, we have Diadem, we have Veriscan. There are a lot of softwares are available which is used in industry for different purpose. So in that, LabVIEW is the most important thing, which is mainly used for application and testing. And there is another software called NI Testan, which is completely used for testing purpose. Fine. So, and when it comes under when we talk about hardware state, we have different families of hardwares. Okay, are available under National Instrument, which is mainly used for application development, product testing on different domains. When we talk about data acquisition system, right? So we have a hardware called a tag family hardware, which is mainly used for data acquisition purpose. And if you want to develop a real-time system, okay, we'll be having another family of hardware called RIO, which is for reconfigurable input-output, where we can develop a standalone system, okay, on embedded as well as FPGA-based applications, right? So we have another family of hardware called USRP family hardware, which is completely used for communication as well as research works, right? So if you want to implement if you want to work on WSN, wireless sensor networks, so we have another family of hardware, okay, called WSN family hardware, where you can build wireless sensor network based systems over there, right? So this is how NI is providing solutions to solve the problems by their hardware as well as their software. Okay, so today we will be working on a tool, okay, called LabVIEW, which will help us to develop an IoT based system. Okay, so why I'm using LabVIEW software? What is the reason? The main reason why I'm using a LabVIEW software is it's going to be a graphical programming tool, okay, which is going to be a graphical programming tool which will help us to solve the engineering problems. As you people are from academics, you people have come across a lot of programming languages. Okay, so most of the languages, if you see, all are going to be what, a text-based programming language. But today, so we are going to see how we can develop an application using a graphical programming tool, right? So, and the expansion of LabVIEW, a laboratory virtual instrumentation engineering workbench. Okay, so it is a high-level design tool which is used for configuration, analysis, simulation. Okay, right. So and also it supports this graphical programming language, right? It supports both software platform as well as hardware platform. If you see here, this software can be used with Linux operating system, Mac as well as Windows, but will always prefer the students as well as the people to use Windows platform, because for Mac, few toolkits will not be supported. Okay, so if you see hardware platform, we have embedded FPGA based platforms where we can develop a real-time system by using this graphical programming language. Fine. So the expansion of this LabVIEW is laboratory virtual instrumentation engineering workbench. Okay. So why it has got a name called virtual laboratory virtual instrumentation engineering workbenches? If you know how to work with this LabVIEW software, okay, if you know how to develop a program with LabVIEW software, and if you know how to work with NI hardware, right? So you can make your workplace, okay, you can make your workplace as an engineering workstation, okay. So that's why it has got a name called engineering workbench, okay. And if you see virtual instrumentation, why it has got a name called virtual instrumentation is, if you know how to work with these hardwares and softwares, right, you can build virtual instrument, or you can build an instrument virtually. What is virtual? Which is not physically present, okay. So where I can build an instrument, okay, or a system virtually by using this LabVIEW software. That's why it has got a name called Laboratory Virtual Instrumentation Engineering Bench, okay. So you can ask the question, okay, you told about LabVIEW, you told about NIS providing solutions in different industry sectors. So then you can ask the question, we want to know where this LabVIEW is used. What are the companies who are using LabVIEW software for their development as well as testing purposes? Okay, the answer for the question. So these are the different companies who are using NI software. Okay, not only these companies, there are n number of companies are there who are using NI technology for their product development, product testing, control, automation purposes and all. Okay, only few things are mentioned in the slide here, which is very familiar to all the people. If you see the company like Boeing, okay, the huge manufacturer for aircraft, okay, they are providing support. They're building aircraft for commercial as well as defense purposes, and you can see we have Siemens, who are the top leaders in the automation sectors, right? We have ABB, and you know about Nokia, fine. And if you see about the automotive industry, see Nissan, Toyota, okay, Ford, or these people are using what? Their NI softwares for their testing as well as application development. programming tool to students, the first thing will be for addition program. Okay, if you work on microcontroller, microprocessor, if you work on C program, Java program, whatever it may be, we'll start with small programs only. Later on, only we'll make our students to work on huge applications. Okay, in that aspect, if you see, when you want to add two numbers, okay, when we want to add two numbers, right, we are going to build a small addition program. When you use C program, right, so we have to use 10 lines of codes. Okay, we have to use 10 lines of codes to develop a program for adding the numbers. Okay, if you see here, when I go for LabVIEW, simple. Okay, now, if you take a calculator, if you want to add two number, what we will do, we'll enter a number, we'll use addition operator, we'll enter another number. If you type equal to, it is going to give a result. The same thing, but if you want to do it in a C or Java, you have to initialize your header files, you have to use some syntax. Okay, or syntax is nothing but we have to follow some steps. Okay, in order to complete the logics. But if you see LabVIEW, okay, so to add two number, we need what? Two inputs. Okay, and to see the result, we need one output variable, and to add, and we need a what? An addition operator to perform the addition. Okay, right. So if you see the difference between the other programming language and LabVIEW, right? So LabVIEW provides, okay, a easiest way to develop your application, and it is completely a graphical programming language. It is not a text-based programming language. Fine. So we'll be having the inbuilt functions over there. Okay, it will be just taking those functions, drag and drop, connect it through wires, run the program. You can easily build your application. Fine. So, and if you see here, whenever we open LabVIEW, so maybe within like 4 to 5 minutes, I'll be using slide, and the next entire session is going to be like a hands-on demo. I'll be opening the LabVIEW software, and then I'm going to explain the concept how we can have build an IoT based system. Okay, so to build an IoT based system, a software and as well as hardware is needed. The software which I'm going to use here is what? LabVIEW software, right? So that's why I'm just telling an overview and about the bird view about this LabVIEW tool. Okay, so when you see here, this is how the LabVIEW coding style will be, right? Adding two numbers, two inputs, one output, and an addition operator, we can complete your addition program. Okay, and another most important reason of using LabVIEW software is what? It has a lot of software libraries. We can easily integrate the third-party hardware over there. Okay, and you can integrate or you can connect your NI hardwares also. Fine. So this is then another reason. And if you see, right, as I told you, the name itself what? Laboratory Virtual Instrumentation Engineering Workbench. Okay. So if you see here, we can build virtual instrument by using LabVIEW software and the hardware. Okay. The best example I can tell you is, again, this two devices or equipment is known to all the people. Okay, one is your CRO and another one is the multimeter, so which is used to measure the information like voltage, current, and other parameters. And if you look on the oscilloscope, where you can just view the information as a waveform. Okay, so these information, this equipment can be virtually built by using NI hardware. Okay, so virtual instrumentation is what? A combination. Virtual instrument is a combination of software and hardware. Okay, so if we know how to work with LabVIEW and NI hardware, we can virtually build the equipments. Okay, see, this is the virtual oscilloscope. Exactly what your real-time what does. Same thing can be done with the help of this virtual oscilloscope. And the next one, digital multimeter. Okay, digital multimeter, so which is used to measure the different parameters like voltage, current, continuity. Okay, all those information. See, it is making our job very simpler. Okay, if you know how to work with NI hardware and LabVIEW software, right? If you want to do any experiments, okay, if you want to do any experiments, right, or if you want to test any circuits, instead of moving into lab by taking all the function generator, oscilloscope, okay, all those things, if you have the breadboard and the respective components in your place, you can just connect it, build a circuit, use NI hardware and LabVIEW software, and you can do complete your experiment on your workplace itself. And if you want to make a remote or IoT based system also, make your system to be connected to the internet, and you can share the information from one place to another place. Okay, so this is an example for virtual instruments where we can make, okay, our workplace as an engineering workstation, right? So if you see here, with this, the explanation about the Internet of Things is over, our introduction to AI technology is over. Next thing is we are going to move into demo part. Okay, so first we'll learn about the LabVIEW tool, LabVIEW software, what are the different functions available here, which will help us to develop an IoT based system. Okay, only the basics, not in depth. Okay, because if you want to learn this LabVIEW tool completely, hardly it takes around 5 to 6 days. Fine. So whichever is required for today, application development, only those options we'll discuss. Next, we'll move on to hardware part. We'll see which hardware we are going to use today for data transfer. And finally, we are going to build a IoT based system. Okay, right? So with this, I'm moving into the LabVIEW programming. I hope you people have installed the LabVIEW software in your systems. Okay, so when you just search your Windows button, if you type LabVIEW, okay, so you'll get the software which is installed here. Fine. So when you just open LabVIEW software, this is a screen which we will get in order to create. Okay, in order to create a VI. Here, each and every programs will be called as VI. VI corresponds to virtual instruments. Okay, so VI corresponds to virtual instrument. So if you want to create a VI, go to file. Okay, so click file and you can see there is an option called new VI. So just click on new VI, or else we have a shortcut called control N, or else we have a shortcut called control N. Click on new VI. Once you click on the new VI, you will get two screens. Okay, whenever you open LabVIEW file, always you will get two screens. One is called as front panel and another one is called as block diagram. Okay, you can ask a question, what is the use of front panel and block diagram? So in the previous slide, I have just told you in SpaceX, they have used LabVIEW software to build GUI, graphical user interface, right? So in order to make a GUI, so in LabVIEW, we need a front panel, okay, and a block diagram. So what is the use of front panel? Front panel is for user interface, okay, where the user can interact with the program through front panel. And you can ask the question, what is the use of block diagram? So block diagram is a place where we'll be developing the application. Okay, so that is a place where we'll be developing the logics. Okay, front panel is for user interface part where the users can communicate with their application through the front panel. Okay, and the block diagram is for programming part. And if you want to see both the front panel and the block diagram parallelly, there is a shortcut called control T. Okay, where you can see both the screens. If you see the difference between front panel and the block diagram, so front panel we have vertical and horizontal grid lines, you can easily identify, and the block diagram will have a empty white space which will be helps to develop the programs. Okay, and as I told you people in LabVIEW, so inputs are called as controls and outputs are called as indicators. Okay, so here we'll not use a word called inputs and output because whenever you see any instruments, right, instruments will have controls and then it will be having indicators. In the same way here also, using LabVIEW software we can develop virtual instruments, right? So that's why all the inputs are called as control and the outputs are called as indicators, right? So if you just right click on the front panel, you'll be getting a palette called control palette where, okay, all the different controls are available. Fine. And if I just right click on the block diagram, I'll get a palette called function palette where all the functionalities for the respective data types and the functions which is available for developing applications will be available over there. Fine. So now if I just right click on the front panel, you can see it is displaying a control palette, and in that you can see there are a lot of sub palettes are available like numeric, boolean, string, we have data containers, right? So these are the different data types which will be supported by LabVIEW. Okay, so NI LabVIEW supports numeric data type, boolean data type, string data type, and we have something called arrays and clusters. Okay, so arrays is group of elements of same data type, cluster means group of elements of different data types. Fine. So these are the different data types that will be supported by LabVIEW over there. And if I just place my cursor on these palettes like numeric, boolean, okay, string, data containers, right, where each and every data types of the respective controls and indicators are available. If I place my cursor on the numeric palette, you can see I have numeric control, numeric indicators, where all numeric control and indicators. You can see these are all also corresponds to the numeric data type only. The appearance looks different. Okay, the small example, a difference between analog clock and digital clock. Analog clock, which you can see the needle movement from one point to another point. When you go for a digital clock, you can just see exactly that time, right? The same way, numeric controls like numeric indicators acts like a digital display, and these controls indicator will act like analog display. If I place my cursor on boolean palette, I'll be getting the respective boolean controls and indicators. Same way for strings and for arrays and clusters over there. Fine. So if you see, all your controls and indicators will be available in the front panel in the control palette. If I right click on the block diagram, I place my cursor on the numeric palette, see all the respective functions or the operators will be available in the block diagram. Boolean, okay, the Boolean functions will be available the same way. Okay, array functions will be available over there. Fine. So this is how you can get your functions and you can get your controls and indicators in LabVIEW. Fine. So the basic thing, as I told you people, if you want to develop a small application, okay, small addition program application, right? So we need two controls and one indicator. Right click on the front panel, go to numeric. We have a numeric control. Just click and place it here. Okay. So this is how your control looks, and you can see here in the block diagram it is enveloped by an orange color. Here one advantage is each and every data type will be represented with different colors here. Okay, that is also one feature here, where each and every data type will be represented with different colors. So numeric, all the numeric DBL data type, okay, fractional numbers, a double precision floating point number, that will be okay covered by envelope box. It looks orange in color. If you see the numeric control, numeric indicators and the wires which carries the DPL value, it will be appearing in orange color. See, when I right click on this control in the block diagram, there is an option called view as icon. If I just click that, it appears like a rectangle box. Okay, and inside they have mentioned DPL. Okay, and if you want to have another control, right click numeric, you can go for numeric control, place it in the block diagram. Okay, so now another one, or else I can give it as x2, x1. Okay, and to see the result, I need an indicator. See, this is an indicator. So result is going to be y equal to x1 plus x2. Fine. So to add two numbers, we have two controls, we have one indicator. Okay, we need an operator. Go to numeric palette. There is an addition function. Click and place it here. Okay. So when I connect this, how we can connect? Okay. So in our breadboard, if you want to connect the components, right, we'll be using wires. In the same way, here also we'll be using wiring tool. Simple. Place your cursor on the controls or indicator, okay, edges. So just click and connect. Okay, see, automatically a wire will be available. See, place a cursor on the border, click. Okay, you'll get black color like structure. It's a wiring tool. Just click, drag, click, and you can connect. Simple. Okay, and here click and connect. That's all. Your addition program is done. Okay, so we can easily complete your addition program by having a control, indicator, and then your addition operator. If you want to see the result, then and see, if you want to run the program, control R, okay, or else you can see file. Okay, if you see there is a menu over there, below that you can see there is a run arrow mark. Okay, this run arrow mark represents run. This will be available in front panel as well as block diagram. If you just give a click, a program will run and automatically it is going to give the result over there. Okay, see, easily an addition program has been done by using graphical programming language LabVIEW. Okay, by having only two controls, one indicator and one operator. So this shows a major difference between a text-based programming language and a graphical programming tool. Okay, so with this, I'll stop for this session. It's 11:32. Please let me know if you have any queries regarding this session. So if you have any queries, any idea, any queries? If you have any queries, you can just post the questions in the chat box regarding IoT, Internet of Things, Industrial Internet of Things, and then about introduction to LabVIEW. Because the next upcoming sessions will be seeing a demo how I can build a real-time system using NI hardware as well as software. Any queries, participants, you can just post your queries in the chat box or you can unmute and talk. No queries. So
Hello, sir.
I hope,
Sir, hello.
yes, sir.
Sir, good morning, sir. Very nice explanation, sir.
Thank you, sir. Thank you so much.
Sir, this LabVIEW software can be interfaced with any other softwares available in EC, like MATLAB.
Yes, sir. We have, you can interface with MATLAB. For that, you need to install a toolkit called MATLAB Simulink. If you install the toolkit, right, so that your MATLAB code can be taken to LabVIEW software and you can do the process. It can be, it is possible, sir.
Is there any other software interfaces like TST or antenna designing softwares?
Actually, for no antenna, maybe for antenna design, you will be using different software. So if you want to make any application or any system, right? So we can completely develop using LabVIEW software, or else we have to check for the supportive toolkits, sir. So we need to check. So if there is any toolkits are available, right? So you can easily interface LabVIEW software with another software. So as of now, regarding MATLAB, I know we have to install a tool called a MATLAB Simulink. So through that, I can call the M files. So regarding DSP and antenna, I have to check. I'm not aware of that.
Okay, sir. Thank you.
Yeah.
Sir, sir, one more normal.
Yes, sir.
In the industrial IoT, now they are telling we'll be using 5G technology. For
Okay.
that, we need to go for MIMO, multi-input,
Yes, sir.
multi-output.
Yes. If you want to
Can
go develop a MIMO based applications and all, right? So in NI, so you can use LabVIEW tool. Along with that, we have another family of hardware called USRP, sir, which is mainly for communication research works and for communication purpose only. So where you can develop software defined radio, you can develop MIMO, that OFDM technology. So all those things can be implemented. But for that, you need to have a USRP hardware, sir. With that USRP hardware, you can develop MIMO based applications. It is possible.
Oh, thank you, sir. Thank you so much.
Yes. Any other queries? Any other queries?
Dear participants, unmute yourself and ask the queries, or you can post in the chat box. Yeah. Or else next session is also going to handle by say a sir itself, Nagarajan sir itself. So if you have any questions, if any queries, you can ask at the time. Sir, we'll have a 10 minutes break, or will you continue, sir?
It's up to, if you want to have a break, you can have a break and we'll continue, ma'am.
Yeah, let's give the 10 minutes break, sir.
Okay,
So
at
now
what
it
time
is
we?
11, yeah, 11:37.
Okay.
So 47,
Yes, ma'am. Yeah, okay, ma'am.
yeah,
Okay.
11:47. So 10 minutes break, dear participants, 10 minutes break, but sharp 11:47. Uh,
The
you
next
can
session
join.
will be started.
Yeah,
Yes.
next session will start. Right.
Thank you, ma'am.
Yeah, thank you.
Oh, thank you, sir. Thank you so much.
Dear participants, unmute yourself and ask the queries, or you can post in the chat box.
Just
Yeah. Or else
put a
next session
message
is
to
also
come
going to
all.
handle by sir.
Yes.
Sir itself,
The
Nagarajan
WhatsApp
sir.
is not working.
So if you have any questions, if any queries, you can ask at that time. Sir, we'll have a 10 minutes break or will you continue, sir?
It's up to if you want to have a break, we can have a break and we'll continue, ma'am.
Yeah, let's give a 10 minutes break, sir.
Okay. At
So now
what
it
time
is
we?
11. Yeah, 11:37.
Okay.
So 47.
Yes, ma'am. Yeah. Okay.
Yeah.
Okay.
11:47. So 10 minutes break, dear participants. 10 minutes break. Sharp 11:47. Uh, next session will start.
Very
Next session
good.
will start.
Thank you, ma'am.
Yeah, thank you. Dear participants, unmute yourself and ask the queries, or you can post in the chat box.
Just
Yeah. Or else
put a
next session
message
is
to
also
come
going to
all.
handle by sir.
Yes.
Sir itself,
The
Nagarajan sir.
WhatsApp is not working.
So if you have any questions, if any queries, you can ask at that time. Sir, we'll have a 10 minutes break or will you continue, sir? It's up to if you want to have a break, we can have a break and we'll continue. Yeah, let's give a 10 minutes break, sir. Okay. At so now it is 11. Yeah, 11:37. Okay. So 47. Yes, ma'am. Yeah. Okay. 11:47. So 10 minutes break, dear participants. 10 minutes break. Sharp 11:47. Next session will start.
Very
Next session will
good.
start. Thank you. Yeah, thank you.
Put a message to come all. Yes. The WhatsApp is not working.
Okay, once again, good morning. So I have seen a query from faculty Swapna. Ma'am, you asked a question, can you give me the advantage of LabVIEW over multi-SIM software? Actually, LabVIEW as well as multi-SIM software both belongs to National Instrument. A LabVIEW software is mainly used for application development and multi-SIM software is mainly used for circuit design. So whenever you want to design a circuit, okay, and if you want to develop a circuit, right, so you have to use multi-SIM software. If you want to test the performance of the circuit, right, you can call the circuit to LabVIEW and then you can test the performance of the circuit. Fine. So multi-sim is completely different and LabVIEW is different. So multi-sim is mainly used for circuit design and development. Okay, like if you want to develop a circuit, if you want to check the response, and if you want to just use that circuit to put it on the PCB board and all. So we'll be using multi-sim. Okay. So if you want to analyze, okay, or if you want to make a closed loop system, or if you want to check the performance of your circuit when we provide a real-time signal, so during that time we will be using LabVIEW software as well as multi-sim. Fine. So it's not like an advantage. By having those two as a combination, you can test your circuit and you can check your real-time response. Apart from that, any other queries? Okay. Is my screen is visible to everyone? Hello. Oh, can you hear my voice?
Not yet, sir. Screen is not shared.
Ma'am, actually it is showing only meeting organizers and presenters can share. That arrow mark is not enabled for me now.
Now, sir.
Yes, ma'am.
Till now you got right.
Yeah. Now it is not showing, ma'am. That arrow mark is disabled.
Oh, okay, okay. 1 minute, sir.
Yes, ma'am.
Or else, sir, once log out and log in, sir.
Okay, ma'am. I'll do that. Ma'am, can you hear my voice now? Yes. Now I'm getting that option. Yeah. I hope now you people can see my screen. My screen is visible? Yeah, thank you. Thanks for the confirmation. So we'll come back to the topic. So we were discussing about what is LabVIEW, also what are the different components of LabVIEW, like front panel and block diagram. So Leo about this connector and icon. Okay, icon connector pan is not required for you people right now. Fine. So now in this session, so we'll be learning how we are going to develop an IoT based application. Fine. So as of now, so we have seen about introduction to LabVIEW and about the data type, and I have just shown you a small program how to do addition program and how LabVIEW program differs from other programming language. Fine. So if you see here, LabVIEW follows a data flow programming concept. Okay, when you look any other text-based programming language, right, we'll be writing lines and lines of codes. Each and every code will be executed from top to bottom, like from first line to the last line. Okay, but here, as it is completely a graphical programming language, right, it follows data flow programming. Okay, you can ask the question, what is data flow programming? So the flow of data from one point to another point is going to determine your order of execution. Okay, this is what we call as data flow programming concept. Fine. So the next part, we'll be seeing about few functions. Okay, and then we'll be moving into the hardware part. Okay, so before that, I'll open the LabVIEW screen, right? I've just shown you only the addition program, right? So if you want to see the other data types available in LabVIEW, if I just go for a Boolean, because I'll be using these Boolean data types in IoT application. Fine. See Boolean data type. So I have took a Boolean control from the front panel, and the same thing is appearing in the block diagram also. Fine. So if you see, when I just right click, and I'll be getting an option called view as icon. If I just remove the tick mark, so that it will appear like a small rectangle box. So I'll use a magnifier so that I can zoom in. Yes. I'll just keep it here. Okay. So if I just see, this is how your control will looks for Boolean data type. See, it is green in color. Inside they have mentioned TF, and if you see the green color envelope, this is the color of the Boolean data type. Okay. And if you want, if I take an LED, okay. If I connect, okay, so this is how the Boolean wire looks. See, it looks green in color. So in LabVIEW, your Boolean data type wires will appear green in color. And if you want to see string, say go to the front panel, string control, place it in the block diagram, and see they are mentioned as ABC. See ABC, and it has pink in color. And I just make it as view as icon. Right click. This is how it looks. Okay, see, and to have a string indicator, I'll place it here. I connect. Okay, good. And if I run the code, the data will be passed. So this is how in LabVIEW each and every data type is represented with different colors. Okay, so orange color corresponds to DBL numeric, a green color for Boolean data type, and if you see any wires controls indicator which appears pink in color, that corresponds to string data type. Okay, so this is an arrays group of elements of same data type. We have another data type called cluster. Cluster means group of elements of different data types. Okay, so these are the different data types supported by LabVIEW, which we can use for application development. Okay, so this is the introduction to the LabVIEW environment and the LabVIEW data type, and then we'll be looking on two functions. Okay, the structure which will help us for application development. Fine. Right. So and now if you see, will depends upon the requirement only. So we will be using, okay, depends upon the requirement. We will be using different data types to develop your application. Fine. So now in front panel, as I told you, it is mainly used for user interface part, where we'll be selecting the different data types with respect to the requirement. Okay. But the most important thing is we'll be working on the block diagram, because as we are the engineers, so our job is what? We need to develop our applications. Okay, so which means that, so it depends on the requirement, we have to use different functions, we have to use different architectures, right, in order to complete your applications over there. Fine. So if you want to save a program in LabVIEW, Control S, okay, or else you can go for file and then you can save. Okay, so when I just give file save, you can just store it in your system on any drive. Okay, so let me go to desktop. I just have a folder over there. Okay, so new folder you can have, right? So I can just mention maybe it's an FTP from Vardhaman. I can create a folder and here I can save the code. Okay, so it's going to be like demo data type. Fine. So the code will be saved. That's all. Okay. So if you want to open another VI, you can go for file and then you can just click on new, or else I can go for a shortcut Control N. Okay, when I just press Control N, automatically a new new VI will be open. Fine. So we'll not go much deeper about the LabVIEW environments because our goal is to develop an IoT based application. So whichever functions which I'm using here, only those functions will be explained. Okay. So now I'll be explaining about two more functions here. Okay. So one, I'll just go to the block diagram part. See, this is a place where we'll be getting all the functions, structures, okay, and which will help us to complete your application. Okay, so in that, if you see, there is a palette called structure palette. Okay, that there is a palette called structure palette. So if you see here, these are the different structures which will be supported by LabVIEW. Okay, in order to do any process. Okay, simple example. When we go for text-based programming, right? Whenever you have a conditional based requirement, okay, whenever you have a conditional based requirement, so we will be using what? If else statement, right? If the condition is true, then you want to perform any action, so you will be using if else. Okay, you will be writing another portion of code, right? So where we can see whenever the condition is false, okay, whenever if you want to take some action, you can go for, you can develop the logic in your false statement. Okay, so when you go for a text based programming, you need to follow what? Syntax. Okay, but as it is a graphical based programming language, syntax is not required here, right? And if you see the same if else statement, okay, the conditional based requirements can be developed, okay, can be applied in LabVIEW also by using a function called case structure. Okay, by using a function called case structure, so we can implement the conditional based requirement. Okay, you can ask a question how it is possible. See, when I just click on the case structure, when I just click on the case structure, I'll close this. Okay, drag, place your cursor on the block diagram, drag it. Okay, this is how your case structure appears. If you want to know the label or visible item label, okay, so this is what we do, 1.8 plus 32. Okay, this is the formula which we will use it for conversion. So I'll go for numeric palette. Okay, so this is your temperature in C. Okay, so into 1.8, go to the numeric palette. There is an option called dBl constant. 1.8. Okay, plus 32. Create constant. I'll go for 32. Okay, and the result will be displayed in an indicator, right? So right click, numeric indicator. It's it here. E in F. Okay, so that I can give it here. Fine. So this is your result, and if you see here, when the value is false, okay, whenever the value is false, I want to see the temperature value as Celsius. Okay, and one concept here, if you see, whenever you try to pass any value from outside of case structure, right? So a tunnel from inside to outside, a tunnel will be created, and this is what we call as output tunnel. Okay, and if you see the tunnel is not completely filled by the data type color, the reason is, so we have one more case called false case, where tunnel is not wired with any other value. That's why it is showing us, okay, it is not filled by the data type color. And if you see, the run arrow mark appears in broken format. The concept is, whenever we try to create a tunnel at the right hand side of case structure, that tunnel is called output tunnel. That respective tunnel should be wired in all the cases, or else your run arrow mark will appear in broken format. So here I want the value to be directly displayed in Celsius when the condition is false. So directly you can connect. I'll mention C/F. Okay. Because when the condition is false, it will be in Celsius. When the condition is true, it will be mentioned in false. Even I can change the label also. For that, I need to do small logics over there. Okay. Even if you want to see that, the label, I can change the label. During the false case, create. There is something called property node. Please don't focus on this. Okay, I'll just change this label around. Okay, so now I have two options here. One is run and another one is run continuously. Run, the difference between run and run continuously. You can ask a question, the difference between run and run continuously. So run continuously means your program will be under execution. When you just click on run button, your program will run only for one time and will come out of execution. Fine. Let me give run continuously. Okay. So
Sir, 1 minute, sir. Sorry to disturb.
yes, ma'am.
Mohan sir, please unmute sir. We are getting a lot of disturbance from your end. Mohan sir. Mohan sir, please unmute. Sir, continue sir.
Yes, ma'am. Okay. Thank you. See, now when I just run the code, okay, when I just enter temperature value as 100, see, I have not pressed the button, the value is in false, okay, so that's why the value is directly displayed. When I just click the button, right, so the true case will get executed, so your temperature value will be converted, like Celsius value will be converted into Fahrenheit, and the value will be displayed in your indicator, okay. So this is how you, and when I just press the run continuous button again, the program will come out of execution. Okay, so this is how you can make use of case structure. Okay, whenever a conditional based requirement comes into picture. Okay, fine. So when you see here, by implementing this case structure, right, you can implement a conditional based requirement which we will implement in your text based programming language using if else statement. Okay, in your text based programming, right, by using case structure we can implement in LabVIEW. Okay, so this is how your case structure works. So only if you know how it works, that's fine as of now, because as we have short time, we have to discuss about the hardware which we use it for IoT based application, and finally we'll be moving into application development part. Okay, so this is the overview of case structure. If you know how it works, that's fine as of now, right? So I'll save this also if you want. So I'll just save this. Okay, hit a save, and now I'll close this new VI. Fine. Yes. So let us move to the hardware part. Okay, which I'm going to use it for today's IoT based application development. Okay, and then we'll come back to a few more concepts. Okay, so today, as the FDP is titled on Internet of Things, okay, so which we have discussed about the IoT concepts, about IoT architecture and industrial Internet of Things, right? So we are going to see a demo. Okay, we are going to see a live demo how we can transfer the data from a hardware. Okay, how when a sensor is connected to an hardware, how we can read the real-time data. Okay, so through when the device as well as the another device is connected through internet as a medium here. Okay, so for that today I have chosen NI technology, okay, National Instrument, okay, which has both hardware as well as software platform. The software which I'm going to use to develop an IoT based application is LabVIEW, and the hardware which I'm going to use for today's IoT development application development is Rio. Okay, the hardware name is called MyRio, which is called which comes under the National Instrument family of hardware. Okay, the expansion for this Rio hardware is a reconfigurable input output. Okay, so using this hardware, okay, we are going to build an IoT based application. You can ask the question, why did you choose this Rio hardware? Because NI has a lot of family of hardwares which is used for application development. So what is the main reason of choosing this Rio family hardware? Okay, the main reason why I have chosen this Rio family hardware, because these hardwares have an processor as well as FPGA inbuilt. Okay, so where I can create a standalone system, or I can create a standalone application or real-time application. When you go for a DAC family of hardwares, where those hardwares will have only the input output circuitries, okay, which will help us for generating and acquiring the information. Apart from the input output circuitries and signal conditioning parameters, this DAC family hardware does not have any processor, or it does not have any memory to store the data, right? And we cannot dump the code also in the hardware. But when I go for a Rio family hardware, it's an embedded based platform as well as FPGA based hardware, where I can develop the application, I can dump the code on the respective hardware, and I can make a standalone system, okay, or I can make a standalone system, or I can develop in real-time applications, okay. And mainly, if you see, today I'm going to use a hardware called MyRio, which is a Rio family, which comes under a family called a Rio family hardware, okay. So Rio stands for a reconfigurable input output, where NI has a lot of hardwares, okay, which is mainly used for application development. If you want to see, I'll show only the Rio family hardware. NI Rio hardwares. Okay, I'll directly go for image. So it's loading. Yes, okay. If you see here, these are the different Rio family hardwares available under NI technology. If you see here, the image which I'm showing now, okay, so if possible, I'll just I'll just try to put the image here. So yes, because this one, with this I can explain all the concepts, okay. So how the hardware will be. Yes, if you see here, this is what we called as compact Rio, okay. So the short form we called as CRIO, okay, which is mainly used for real-time application development. So you can ask, like, what is the advantage of using this hardware, sir? Okay, this hardware is rugged in nature. You can use it in any environment, and the most important thing is it has an FPGA inbuilt, and it has a processor also, where you can create a standalone system, okay. So once you develop an application, as it has a processor here, you can just dump the code in the processor, and you can make this hardware to work on its own, okay. So no need to be always interfaced with your computer in order to have a data transfer, because this has a processor, it has RAM, it has ROM, it has memory, okay. So we can dump the code, and we can make your application to be a standalone. And another one, this hardware has a capability to interface with internet, okay. So where you can have a data transfer, okay. So you have an option to connect your Ethernet ports over there, okay. And if you want to have a data logging, okay, if you want to connect a USB camera, or if you want to connect a pen drive where you want to log the data, we have a separate slot over there, insert it, and you can just make a data logging system also, fine. And if you see, as this hardware has FPGA also, where you can develop your program either in processor as well as FPGA, okay. Or else you can just make use of the processor as well as FPGA in an efficient way to develop the applications, right? And if you see here, so we have something called as modular input output. So these are called as C series modules, okay. We call these are actually C series IO modules. For example, what is the use of having this hardware? So in order to acquire the real-time data, okay, if you're going to use any sensor which comes under analog in nature, you can go for analog input output module, or else if you are going to have any measure any parameters, and if it is a digital data, you can go for digital input output module. Okay, so like this depends upon the requirement. We'll be selecting the modules, and the modules will be inserted on the chassis. Okay, and it is hot swappable also. During a program also, you can just plug and play this chassis, but this IO module will not recommend that. Okay, so this hardware is the most powerful hardware, okay, which comes under Rio family, where you can develop a standalone application. Okay, fine. So like this, we have n number of NI family hardwares are available. If you want, this is how your I'll show how the chassis looks. Yeah, see, so this is how your compact Rio looks. So right, this is what we call as chassis. At the backplane of the chassis only your FPGA will be available. All the IO modules will be directly connected to the FPGA pinouts. Okay, so this is the place where we'll be inserting all the IO module. This is one family of hardware. So today we'll be discussing about, or we are going to develop an IoT based application by using a hardware called NI MyRio. This is a hardware which I'm going to use it here. So it has an ARM processor as well as FPGA inbuilt, and it has an option to generate a Wi-Fi signal, and it has an option to connect with the existing Wi-Fi, and we can have a data transfer. Fine. So this is one family of Rio hardware. So we have another family of hardware called SB Rio. Okay, and this one we call as Elvis 3 Plus. This is also an hardware which is mainly used for academic purpose. Okay, as you people are from academics, right? If you know how to work with this Elvis 3 hardware, you can just develop a code under RT or FPGA, and you can do all your laboratory experiments. Okay, whatever the experiments you do in your laboratories, right? Analog, digital, as okay, analog. You have analog devices lab, electronic devices lab, digital circuits lab, right? All those experiments can be done and developed by using this Elvis 3 hardware here. Fine. So like this, we have different families of Rio hardware, which is mainly used for application development. Fine. So now I'll go back to the PPT part. Fine. So this is the architecture. Okay, this is the architecture of this Rio hardware. So this Rio family hardware. Okay, and you know when you know how to work with one Rio family hardware, right? The programming way which we follow to develop an application, right? So the same steps, okay, you can develop for use for any other Rio family hardware to develop the application. It is not like for each and every hardware you have to learn different programming language, different steps. No, okay. So only the configuration will change. Okay, the configuration parameters and a few setting parameters will change, but the programming, the way which we program is going to be same for all the Rio family hardwares. Okay, if you know how to work with my Rio hardware, you can easily work with C Rio or your SB Rio. We have Robo Rio, we have Flex Rio, right? So there are different families of Rio hardwares are available where you can work on it. Okay, so these are all the different hardwares which is used in industry for making real-time applications. Okay, you can ask a question why we have to go for Rio. Okay, because this Rio is mainly used for standalone systems, right? And when we talk about a word called real-time applications, okay, always when you talk about any applications, right? So you'll just tell me, I want to build a real-time system. Okay, I want to build a real-time system. So what is the difference? Okay, so when we go for developing a real-time system, right? And if you see this compact Rio, okay, if you see this compact Rio, so this has an ARM processor inbuilt. Okay, it will have ARM or it will have an Intel processor, and it has a Xilinx FPGA over there. It has modular input output. It has an integrated processor in iOS where you have connection to have gigabit Ethernet, USB connection, serial connection. All those things will be available. And if you see, okay, the operating system which they use, okay, the operating system which they use is going to be a Linux operating system. They will not go for a Windows-based platform. Okay, why they will not go for Windows-based platform? Because the Windows-based platform we call generally as GPOS, General Purpose Operating System, which is going to do a multitasking application where you cannot go for priority-based. You cannot go for prioritized-based applications. Okay, so whenever you want to make a critical-based requirements, right? So if you want to set a priority, that will not be supported by your general purpose operating system, and that will not be satisfied at a given right time. Okay, but when we go for a real-time operating system like Linux, that is only meant, okay, and that the only job which your system is going to do is what? Running and monitoring the application. Apart from that, parallel will not do any other process. Okay, that's why always they'll go for RTOS based systems. Inside that they'll be using Linux. Okay, they'll not go for Windows based operating system. We call that general purpose operating system, because GPOS will do multitasking and we cannot go for critical based application. And prioritization is not, if you prioritize also prioritize your task also, we cannot guarantee that that will happen at the right time. Okay, and if you want to make your program to be deterministic, reliable, okay, if you want to reduce the jitter and all, the best thing is always will be going for Linux based operating system, will not go for Windows based operating system. I can tell you a best example. So everyone knows about the cars. Okay, so cars will have safety airbags. Okay, car will have safety airbags, which will help us to protect the drivers as well as the passengers inside the car when they met an accident. Okay, fine. So if you see, right, so whenever the car hits, okay, whenever the car hits a barrier at a frequency, okay, automatically the airbag, without any delay, it comes out and it is going to safeguard the passenger. Okay, so if we use a general purpose operating system, right, we cannot guarantee that at a given time, at that instant, the airbags will come out and it will safeguard the passenger, because it is going to do multitasking. The processor is shared for different tasks, right? So if there is a small delay also, the entire people, the passengers inside the car will get injured. Okay, so in those kind of critical based applications and all, we will not go for general purpose operating systems. So that's why always whenever we want to make a real-time system, right, we'll go for Linux based operating systems over there. Okay, so if you see right, so Rio, okay, the Rio hardware is also having what? A Linux operating system inside that. Okay, so this is the architecture for your Rio hardware. Okay, the Rio hardware will have a processor, it will have an FPGA, and then it will have an analog input outputs, and it will have custom IOs and digital input outputs over there. Fine. So if you see this hardware, okay, it has real-time operating system, and it is like a same computer. Okay, for example, when you buy a computer, first you have to install operating system, and then you need to use the install the application software which is required for you to work on your laptop. In the same way, whenever we have the Rio hardware, so we have to first install the operating system, and in order to develop the application side, we need to install the respective application softwares and the drivers, okay, inside this hardware. Okay, fine. And as I told you, it has an FPGA processor as well as IOs, right? As all the input outputs are connected directly to the FPGA IO, there will not be any delay, okay, between the IO terminals and then your FPGA systems. Okay, as it is directly connected, the values will be directly passed to the FPGA through processor and will get processed. Okay, and here it is not like always you have to develop either code only on FPGA or only in processor. We can make use of processor as well as FPGA in an efficient way to develop a standardized application. Fine. So this is the architecture for Rio hardware. Fine. So for today's session, I'll be showing a demo on my Rio, okay, so which is called reconfigurable input and output, okay, the expansion, so which we can use it for control robotics and other application development process. Okay, so I am using this hardware for today's demonstration. So why I have chosen this hardware, as it has an embedded processor FPGA inbuilt, and I can develop a standalone system. The most important thing is this hardware has a capability to generate a Wi-Fi signal up to 150 meter. It has an onboard Wi-Fi, or else we can connect this software with the hardware with the existing software or existing internet, okay, available, and we can have a data transfer. So that's why I have chosen this hardware for an IoT demo. Okay, right? So now if you see, this hardware has some onboard LED devices. Okay, this hardware has an onboard devices. Okay, if you see here, it has a 4 user LED. It has a 4 user LED. Fine, right? And it has an accelerometer. It has an onboard accelerometer. It has a push button, so where you can make use of it for your application development. Okay, right? So now, if you see, as it is an electronic device, right? it needs power supply, so it needs 6 to 16 volt power supply, and you can see there is an option called device, so which will help us to connect your PC and your Rio hardware for code development, okay, code deployment. At the same time, if you want to do any configuration settings, make sure your Rio as well as your system should be connected through your device, and you have an USB port which is for connecting your USB based devices, right? Now if you see here, the pinouts, okay, if you see what are the different types of IOs which can be connected and read using this hardware. So this Rio hardware has actually totally 3 different ports we call as MSP. For this one, the thing which you are looking in your screen is called MSP port, which is called as mini system port, where we can interface analog sensor, digital sensors. Okay, so it has digital input output. Totally, it has 8 digital input output pinouts, where you can just make use of these pins either as digital in or digital out, or you can use the combination. Okay, few pins as DI, few pins as DO. At the same time, if you want to generate a PWM signals, you can go for DIO 7 and then DIO 3. Okay, and you can just make use of, okay, so you can make use of this pinouts to connect your analog and digital sensors, right? So now next, if you see, we have 2 more. Okay, if you have 2 more pinouts, one is called MXP A port and MXP B port. Okay, these has 2 ports, A port and B port, right? Which is used for connecting your sensors. Okay, so it has analog input pins, it has analog output pins, digital input pins, and digital output pins. Okay, fine. So if you see here, if you have any protocol based sensors, okay, if you have any protocol based sensors like SPI, UART, and then I2C based sensors, right? Those sensors also can be connected using this MXP port, and you can acquire the data, fine. So which means that this hardware supports serial communication protocol. So like this, there are n number of advantages are there when we go for this Rio hardware. That's why I have chosen this for today's demonstration. Okay, so now let me show how we can connect this hardware, how we can develop the program, fine, using this Rio hardware. So I'll just connect the camera and then I'll show how I can make use of this hardware. Okay, just a moment. Okay, so I have a cam with me. So with that, I can just show. I'm sorry, disconnected the hardware. Yes. So now, if you see here, I have a cam connected, USB cam. So let me open that and then I'll show the hardware. Yes, you can see this is the hardware which I'm going to use for today's application development. See, this hardware is called MyRio, okay, which is called reconfigurable input output. I hope you people can see the device. As of now, I have connected my hardware through Wi-Fi. So if you look, it has, I can show you clearly. Okay, so it has user LED, it has, see, power LED is on, which means the device is powered, and the Wi-Fi LED is on, which means my device is connected through Wi-Fi, and it has an onboard user LEDs. Okay, see, it has an onboard user LED 0, 1, 2, and 3. Okay, and this device is connected through internet now, and it has a push button as well as it has a Wi-Fi reset button. Okay, see, this is the hardware which I'm going to use it for today's IoT demonstration. And if you see here, this is the port, okay, which we called as MSP port, okay, mini system port, where it has 8 digital input output pins, analog input output pins. And if you look here, these two, okay, so these two ports, okay, so this is what we called as MXP A port and MXP B port, okay, where you can just interface your communication based, serial communication based, protocol based sensors, and you can have a data transfer. Okay, so as of now I'll be using these hardware, okay, for your application development, right? And you have an option to acquire and generate audio information also through this hardware here. Clear? So this is the hardware which I'm going to use for today's application development, and it is configured through Wi-Fi. If you want to check, see, I'm removing this USB connection also, which is not required for me right now, because as I've connected my hardware through my Wi-Fi, right? See, only the power, okay, the power cord is connected with this hardware. Apart from that, okay, we don't have any connection with the hardware to my personal computer. Okay, so this is how we have connected. Now let us go for application development. Okay, next step is we'll be moving into application development. So I'll just stop the grab. And if you want to see whether the hardware is connected with my system, okay, you can see there is an option called remote system, and see there is an option called NI MyRio. So this is the hardware which is connected with my laptop through Wi-Fi. I've just used my mobile internet to connect my system as well as my Rio hardware to be connected on a same local network. You can see this is my Wi-Fi name. Through Wi-Fi only my device is connected. That's why my Wi-Fi LED is glowing in blue color. Okay, and if you see the IP address, it is 192.168.43.253. So this is going to be the IP address. Okay. So now let me show how to connect this device and how we can develop logics. Okay, how we can develop the logics to read the information, okay, from this hardware. As it has an onboard sensors, okay, let us show, let us see a small demo how I can just read and write the data from this device, okay, to my application through wireless mode. Next, we'll see how we can have a data transfer between two different devices when it is connected through local network. Okay, and then we'll see cloud demonstration. Okay, so the first step here, I'll go to LabVIEW. Let me close this. I have to create a project now. File, I'll close this also. First, let us see how we can have a data transfer with my mobile phone and then this hardware. Okay, so LabVIEW file. There is an option called new. Okay, click new. So create, select empty project. Okay, a project will be created. Okay, so yes, if you see here, I have a project only, it has a computer, so I need to add my target. Okay, so right click on your project, new. There is an option called target and devices. Okay, so you can see you'll get this pop-up. So here you have to select MyRio. Okay, expand MyRio. See, it will detect the hardware. Okay, it will detect the hardware. Right, you can see now the hardware is displayed here, and if you just click on OK, the Rio hardware is detected, and that will be available under your project now. Okay, it's loading. So once it is added to the project, we can develop the code. See, it is discovering the device, and this will be added under your project now. Okay, so it takes few seconds or a minute to add. Yeah, done. It's added now. You can see here automatically your Rio hardware is added under your project. And see, this is my IP address 192.168.43.253. And if we expand, as I told you, it has an FPGA as well as embedded processor inbuilt, right? So you have an FPGA target also. So now to develop a new VI under RT. Okay, right now I'm not going to work with FPGA because it takes huge time to compile and develop the code. Okay, you have to learn more concepts about FPGA. So that's why I'm directly using RT. Okay, let me use a real-time processor to develop the application. So that's why, see, I'm just selecting my Mario processor RT. Okay, new VI. So now automatically a VI will be added under my Rio hardware. It will not be added under my computer. See, the hardware untitled file is available under this Rio. It's not under your my computer. So now let me save this program. Okay, so I have to save the project. I have to save the program also. So it's loading. So I need to get the screen. Yes. Okay. Create a folder. Video project. Untitled one. Project is saved. Okay. It will be as untitled one. So we have to save the code and go for video demo. The VI is also saved now. Okay. And now if you see, this is the front panel of your application. And I'll go to the block diagram part. I'll expand here. Okay. So right now, as of now, I'll show how to use the onboard devices. A later part, we'll see how we can interface the sensors. Okay. So right now, I'm going to show a demo for IoT based application also by using this onboard device only. Fine. So to develop the code, right click. Okay. You can expand. You can just see there is a palette called MyRio. Okay. There is a palette called MyRio. Inside this only, all your IO functions will be available. Okay. So as I'm going to use the onboard device, my hardware has one push button. It has an LED. Okay. So let me take the push button and then place it in the block diagram. Okay, this is the button. You okay now? So it has to get configured. Okay, and next step, I'm going to use an LED's onboard LED. So go to my Rio palette, LED, place it here. So let me use LED 2. Okay, or else I'll use LED 3 alone. Okay, so now the LED will be configured. Okay, and directly I'm connecting the button and the LED. To run the program continuously, you can go for run continuous, or else I can go for loop. Okay, so let me use a while loop here. See, I'm introducing a new concept called while loop. So whenever you want to do any process in a repetitive manner with respect to conditions, you can make use of loop here. So this is how your while loop appears in LabVIEW. Whatever the code you develop inside this while loop, right, it's going to run continuously with respect to condition. And this while loop has two terminal. One is called iteration terminal, which tells you how much number of times a loop executes, and it has a conditional terminal. And this conditional terminal is configured as stop if true. When I right click, you can see it is configured as stop if true, which means that it can, whenever it reaches its stop value, it will come out of execution. So that's why when I right click create a control, a stop button is automatically created. Okay. So and when we use loops, always we have to use a delay function in order to reduce more amount of CPU usage. Let me use 100 millisecond delay. So it is a demo. That's why I'm not giving more time for you people to take a hands on. Okay. So I can show only demo as we have only less amount of time here. Fine. So when I run this code, okay, usually when you run the code, your program will immediately run. It will show the output, right? But when we use Rio hardware, okay, it's going to first deploy. Okay, the code will get deployed in your hardware through Wi-Fi. Okay, because it is connected through Wi-Fi now. Once it is deployed, your program will automatically starts to execute. Okay, if you want to check that, I go for NIMAX camera graph. Okay, see, it's now the code is deploying. Okay, that's why that Wi-Fi LED is blinking now. If you see it is asking to save. Yeah, once it is deployed, the program starts to run, and now you can check. Okay, see, there is a button here. This is your push button. When I press the button, your LED, this one, the LED which is placed here, that will get turned on. And see, apart from this power cable, the Rio hardware is connected with my system using Wi-Fi. Okay, so when I press the button here, just keep it like this so that you can see the LED gets turned on. I press the button. Okay, the button is available here. This is the button. Okay, through Wi-Fi. See, I'm dumping the code and I'm executing the code also. Fine. So this is one where we can configure, deploy, okay, your code using Wi-Fi to this MyRio hardware. So next we are going to learn how we are going to have a data transfer between, okay, LabVIEW targets when it is connected to local network. That is going to be a demo. So for that, if you see, I have a mobile phone. So now I'm going to show how I'm going to transfer the data from my mobile phone to Rio and from Rio to mobile phone when these targets are connected to a same network or a local network. Okay, so this demo we'll see now. So before that, okay, I'll stop this code and we'll go for the application development. Okay, fine. So now I'll stop this graph. I'll go to the presentation. Okay, so we are going to learn how we can have a data transfer when the systems are connected to local network. Okay, if you see edge devices here, they're going to have this Rio hardware for edge device. Okay, where it is going to sense and transfer the information. So the connectivity here, we are using what? Wi-Fi. You have GSM, Wi-Fi, LoRa, and Sigfox. So I'll be using this Wi-Fi to have a data transfer. Okay, right? And then that, if you see here, so I can use, okay, whenever the different targets, okay, the targets are connected to the local network, when all those targets are LabVIEW targets, which means whenever they have NI applications which is present in the systems, right? So I can transfer the data either using shared variables or else I can go for network streams. Okay, so if I have non-LabVIEW targets, I can go for TCP/IP protocol or else I can go for UDP protocol in order to have a data transfer. Now I have installed an app called Data Dashboard application in my mobile phone. Okay, so through it is and that app belongs to National Instrument. Okay, so I have a LabVIEW target. My mobile phone is also now a LabVIEW target, and my MyRio hardware is also a LabVIEW target. So I'm going to show a data transfer, okay, between my mobile phone and then this LabVIEW application. Okay, by using what? Shared variables. Fine. So we'll see a small demo right now. I'll show this video also. Okay, so how it is happening. I'll go to LabVIEW. Fine. So as of now, the program is still running. If I press stop button, it will come out of execution. See, as of now, when I press the button, the LED is getting turned on and turned off. Okay, so now I'm not going to use a button. Okay, now I'm not going to use a button. See, I have LED 3. Okay, I have LED 3. When I press a button in my mobile phone, okay, when I press the button in a mobile phone, so automatically, okay, so the LED, the Rio LED should get turned on and turned off with respect to the command which I'm giving through my mobile phone here. Okay, so for that only we have to use what? Shared variables. Okay, we'll be using shared variables, or else we call this as actually network shared variables, right? So right now we'll see how we can make use of this shared variables. Okay, so in LabVIEW we have different types of variables are available. Okay, so one we call it as local variables, which is used to transfer the data in a single VI. Second, we have global variable, which will be help us to transfer the data between multiple VI. Third, we have network shared variables where we can transfer the data with different targets, okay, with different LabVIEW targets. So today I'll be using a shared variable in order to have a data transfer from my mobile phone to my Rio hardware. Okay, so for that, so I need to use these shared variables. At the same time, my Rio hardware has an accelerometer. Okay, Rio hardware has an accelerometer. So my Rio, I have accelerometer here. Okay, this is a 3-axis accelerometer which is used to measure the tilt, vibration, and the acceleration, right? So I'm going to measure the z-axis value in my mobile phone. Okay, not in this, not in my front panel of this application. So I'll be this viewing the value of z-axis, okay, that in my mobile phone. Okay, by how? By using shared variables. Okay, let us see how we can have a data transfer between my Rio hardware and this mobile phone. Okay, so for that I'll be using what? Shared variables. Okay, so in order to use shared variables, I'll go to the project screen. Sorry. Okay, I'll go to the project screen. I need to create a shared variable. Okay, in order to create a shared variables, so right click on your Rio target, new, there is an option called variable. Okay, when I just click on variable, automatically a new library will be created. Okay, a new library will be created, and then it will pop up a message. Okay, it will pop up a message which type of variable you want to create. Okay, so let me give this as switch. Okay, switch. See, it's network published variable. Data type, it's going to be Boolean data type, and I provide okay, and you can see a library will be created, and you can see untitled library switch, a shared variable is added. Okay, so I'll go for magnifier. I need to add how many variables? One more variable. Okay, one more variable to view the accelerometer data. For that, again, don't right click your Rio and go for new and select variable, because already a library is available. So right click on the library, new, select variable. Okay, so it's going to be ACC data. So ACC, I'll just mention in short form, it's a DPL value, provide okay, see, and another variable is added. Okay, right? So if you want to give any string information also, if you want to read a string data from your mobile phone to LabVIEW, I'm going to add one more variable. Okay, data or else message. Okay, so and it's going to be string data type. Okay, see, 3 variables are added. So file, you go for save, it will automatically ask you to save the library. So see, it will extension will be .lib. I'll create the library name as FDP library. Okay, FDP library, I'll give enter. So automatically the library is also saved now. Okay, see, library is saved, your library shared variables are created. Next step is how to call those shared variables to your block diagram. Okay, there are 2 different ways to call your shared variables to block diagram. One, structure palette, there is a variable called shared variable. Select and place it here. Okay, if you place it here, it looks black in color. Place your cursor. Okay, kindly watch it. Place your cursor on the shared variable, you'll get a finger symbol. Click select variable, and this is your hardware. See, this is your library name, and if you want to take a switch, select switch. See, automatically a shared variable will be created, and wire it. Okay, this is one method. Another easiest method, place your project screen in your block diagram parallelly. Okay, select the shared variable, drag and drop it in the block diagram. This is one method, easiest way. Okay, so by default it will be in read mode, so you can have change to, sorry, go to access mode, change to write, connect. Okay, so one more, we have to see the message. Okay, so if you want to share any message on the front panel, see, I don't have any controls here, only stop button to stop my program. String, okay, this one, string indicator, This is just to display message. Okay. I'll just keep this here. Okay. So now your code is ready. The only thing is we have to, okay, we need to call the shared variable to display the message. Structure, shared variables, view, library. This is one method. Another method, message. A shared variable will be added. Connect. Okay. So now your program is ready. Okay. Only thing is we should learn how we should have a data transfer. Okay. So for that, I need any desk to connect my mobile phone. In desk. Okay. So I can show my mobile screen in the laptop itself. Okay. That's why I'm opening any desk. View screen as well as Rio. I'm going to connect my mobile phone with this AnyDesk. Just a minute. You can see how it is connected. So AnyDesk, it's going to be 40535. Yeah. Okay. See, this is my mobile phone screen, which you can see now. Yeah. Right. So if you see here in this, I have an app called Data Dashboard Application. See, it's placed here in my mobile. Okay. Let me select Data Dashboard. So it's in dark mode. I'll just disable it. Yeah. Now you can see Data Dashboard. Okay. So now I'm going to create a VI. Okay. How we'll create a VI in Labby? We'll go for file and then new VI. In the same way, see there is a plus symbol here. You can see there's a plus symbol. If I just click the plus symbol in my mobile phone, automatically a new screen will be created. Okay. And this is like a front panel of your lab view. This is a place where we'll be having your controls and indicators. Okay. Next question you can ask, how we can add the controls and indicator. See, there is an option here which I'm highlighting through my mouse. Okay. So I have to click that. So in my mobile, if I just click, I'll get indicators and controls. So I need how many indicators? Two indicators. Sorry, one indicator, that is to display my accelerometer value that I want to see in a waveform chart. Click on waveform chart and tap down. Okay. See, you have to click and you have to tap on the screen here. That respective controller indicator will be placed here. Okay. Again, go back. You can arrange it. Okay. I'll place it here. Next, I need a control switch. Place it here. Arrange. Okay. And if you want to send a message, you need a string control string. Okay. See, I just placed all the controls, all the indicators which is required here. Fine. Now I'll go to the code. I'll run the program. Okay. It is asking to save. Deployed. The program is ready to run. Okay. I'll minimize the screen so that you can see all the data. Block diagram is not required. Yeah, you need to see only this AnyDesk. Okay, fine. See, now here also I'm going to configure. Okay, so there is an arrow mark right here. There is an arrow mark here. Click run. Okay, right? If you just click here, it will get executed, or else you can just give stop here. This is to run. Okay, now we need to configure each and every controls and indicator with the shared variable. Okay, so for that you can see you'll get a hyperlink here. This one. Okay, which I'm highlighting on the screen now. Click that. Okay, it will ask you shared variable. Select. You have to enter the IP. Okay, so I have to enter the IP which is available here. So I'll enter, see, 192.168.43.253. When I just give connect, see, it will show my library names. Okay, what is a library name? FDP library. Click on FDP library. Okay, so I want to configure accelerometer data. Select, it's configured. Next, switch. Sorry, switch, shared variable. Select the IP, library, switch, configured. Next one, string, shared variable, library, message. Okay, all are configured now. I can just run the code. Run. See, when I just click the button, okay, your device will get turned on. And if you want to see the string information, see, I'm going to type now. Good afternoon. Okay, when I just give enter, see, that message will be displayed in my screen here. I'm typing in my mobile phone, that will be displayed over there. If you want to check that. Hope you all are doing good. When I enter, see, that message will be displayed. And if you want to see whether your Rio LEDs get turned on or turned off, when I press the button here, I'll go for NI Max, AnyDesk, maybe I'll minimize and I'll show this also. Which I'll place it here. Okay, sorry. I'll just go for this grab. Okay, you can see my Rio hardware. Fine, and you can see this ADS screen also. Sorry. See, when I press the button, the LED is turned on. Okay, see, when I press the button here, see, sorry, you have to look here. See, when I press the button, the LED is getting turned on and turned off. Okay, right? So this is how you can just use your data dashboard applications whenever you want to have your data transfer between two different targets when it is connected. Okay, using NI technology, whenever you have two different LabVIEW targets, when it is connected to a local network, we can have a data transfer. Okay, fine. So this is a small demo where we can implement, okay, or we can transfer the data by using Internet of Things, by connecting your hardware through this Rio, where we can have a data transfer. Fine. So this is a small demo. So where we can share the data among two different targets when it is connected through local network, and by using internet as a medium, right? So we are transferring the data over there. Okay. Please let me know if you have any queries. Any queries?
Dear participant, if you have any queries, you can ask me. Otherwise, you can post your questions or queries in the chat box.
Any doubts, any queries, please let me know.
Hello, sir.
Hello, yes, sir.
Sir, in case if you are using any temperature sensor or any industrial sensor, can we know the
Yes, sir.
data rate? How much data it is transferring?
Like a data rate speed, sir.
Yes, sir. How much bits per second it is transferring? Like that.
So actually now it is an we are using an normal digital sensors. If you use an analog protocol based sensors, right? So we have to
Yes.
follow the instructions how we can have how we have to configure the registers, and then how we have to transfer the data. All those things we need to programmatically develop. Sir, we have speed actually. When we go for protocol based sensors, like so up to 100 Mbps, we can have a data transfer, sir, in MyDio hardware. So that
Sir, that
only
we
we can
can,
configure. Yes, sir.
sir, that we can visualize using LabVIEW, sir.
No, sir. It is internally built that we cannot visualize. The speed we cannot visualize here.
But we can calculate.
Yeah, we can.
Okay, sir.
Yeah.
Thank you.
We have an option here for this Dio hardware. We can transfer up to 100 kbps. So where we have ultra speed also, that this hardware will not support when we go for higher end versions of NI hardwares like PXIs or Sirius and all, where we can have a high speed of data rates. Data transfer can be done. Any other queries? If you have any queries, please let me know. So in the same way, we can push the data to cloud also. If you want to access the Google Firebase cloud, if you want to have a data transfer, that is also possible by using this NI hardware. Any queries?
Can we contact you in future, sir, for any help?
Yes, sir. Yeah, sure. So if you want any support related to NI technology, so you can have my contact number. So this is my email ID, contact number, as well as my name is mentioned over there. So this is my WhatsApp number. You can text me in WhatsApp. So if you have any queries related to NI technology, or if you're looking for any support for students, workshops, or value added courses, programs, or internships. So because as we're the technical partners of National Instrument, right? So we work on actually industry project. At the same time, we'll be supporting to a lot of academic institution. On supporting students and faculties for conducting software as well as hardware-based workshop, which is related to industry concept. And we are supporting students for certification program also. So Vardhaman College people are very known to us. So where we are having an memorandum of understanding, and we are supporting them on project developments as well as certification trainings, workshop as FTP. So we're supporting to most of the colleges across India, and we are providing internships also for students. So you can just have my number. If you want any support related to NI technology, you can contact me. So if you want, I can just post my information in Hangout, this chat box also. You can use it. I just posted over there. I just type.
Thank you so much, sir.
Thank you, sir.
Any other question from participant side?
Any queries? If you have any queries, please let me know. Ma'am, we have time, or it's end of the session now, ma'am. Do you have time now?
Yes, sir. Near to end of the session, sir.
Okay, ma'am, fine. Yes, it's up to you, participants. If you have any queries, you can just reach me through my number or contact email. If you're looking for any support related to NI technology, we are open to help you. I hope this FDP program gives you an idea about what is IoT and what is Industrial Internet of Things, and how we can implement IoT based applications using NI technology. I hope this gives a new idea for you people.
If participants, if you don't have any queries, I would like to convey vote of thanks to today's speaker. Thank you so much, sir, for spending us your precious time and sharing insightful presentation on IoT architecture and
Thank you, ma'am.
industrial.
orientation Ashalata madam.
Yes, please, participants, mute your mic.
Continue, madam.
Participants, please mute your mic. So thank you, sir, for sharing the presentation on IoT architecture and what is IoT and how it does it work, and graphical program, how the graphical programming tools in software engineering problem. We hope all participants get benefited with this presentation, and I want to thank you once again on behalf of the FDP team and from the entire participant.
Thank you. Thank you. Thank you so much, ma'am. Thank you, participants. So,
Thank you, sir. Nagarajan, sir. Thank you.
Thank you, madam. Thank you so much, ma'am. Ma'am, shall I end the session, ma'am? Shall I leave now?
Yes, sir. Yes, sir. You can leave.
Okay, madam. Thank you, ma'am.
Dear participants, you can leave the session and again we'll meet tomorrow morning 10 o'clock. So we have 2 sessions tomorrow, same timing 10 to 1:10. So we'll meet at 10 o'clock tomorrow. Thank you.
Thank you, madam.
Feedback link is posted. Just fill the feedback link. You can check in the chat box.